Okay, so we're going to take a look at another problem. So this one also deals with density, and this is a two-part problem. All right, I find a ball bearing in my classroom. The mass of the ball bearing is 22 grams, and the radius is 1.9 centimeters. Okay, so I've got the radius here. Looks good. Fine. So I've got a ball bearing that I have found, and its radius, let's see, the radius, R, is equal to, what did I say? 1.9 centimeters. Kind of a big ball bearing. That's about 3/4 of an inch in radius. So that puts it at about 1.5 inches in diameter. That's pretty big. That's bigger than any of the ones that we work with in the lab. That's okay. The mass I found to be 22 grams, which is actually kind of light. But let's see. I asked what the density is. And once again, our answer for this one must be within 2%. Some of them need within 1%. All right, here we go. So we want density. Density is rho is equal to our mass divided by our volume. So part one is we're trying to find the density. Okay, well, we've got the mass, but now we need the volume. This is a ball bearing, so it is a sphere, which means we're going to use the equation like we saw in class. The volume of a sphere is equal to 4/3 pi r cubed. Well, on the upside, we know 4, we know 3, we know pi, and we know the radius. So the volume for this ball bearing will be 4/3 pi 1.9 centimeters quantity cubed. And I say quantity because it's not just the 1.9, it's the 1.9 centimeters. All of it gets cubed. All right, I quickly plug this into my calculator. 1.9 raised to the third power. It's going to be times pi times 4 and divided by 3. You can put this in however you'd like, but you should come up with something like 28.7 to 3 significant figures. It's 28.73 if you want another one. And the units, there are no units here, no units here, and we had centimeters, but it got cubed. We ended up with centimeters cubed, which is the proper units, at least that we're using, for volume. Great. Now we've got the volume, we can take it and the mass. The mass was 22 grams, and we now know that the volume is 28.7. So if I want to set up for my density, I'll have 22 grams divided by 28.7 cubic centimeters, or centimeters cubed, however you want to say it. And we will find that our density, which is the first thing we're looking for, is 22 divided by that, should come up to something like 0.766. It's actually 0.7657, but rounding it to 3 significant figures, I get 0.766 grams divided by cubic centimeters, grams per cubic centimeter, which are the units of density. Great. Actually, my numbers seem to come up where this is pretty close to some of the ball bearings that we worked with. In fact, what am I talking about? Right here. We've got one of the wooden spheres. If you remember the density of this, we thought it was birch, if I'm not mistaken. Actually, it does come up to pretty close to 0.76. Although, what was it, 6.7? Something like that. Anyway, so we have something that's pretty large, relatively light. In fact, this one's probably going to be wood. You might end up with something a bit different because everybody gets different numbers. All right, part 2. Part 2 says, what would be the mass of the ball bearing if it were made out of pure gold? The density of gold is 19.3 grams per cubic centimeter. So this is part 2. And this time, we're going to go through and we're going to try and predict what the mass will be if this were gold. Okay. This time we're going to use the density of gold, which is equal to a whopping 19.3 grams per cubic centimeter. This is something that doesn't get brought up much. Gold is really, really heavy. Now, it's a soft metal, but it's also really, really heavy. Something to keep track of. In fact, we're going to find out if we had an object about this size, roughly, made of gold, how heavy it would be. It won't be 22 grams. That's way too light. All right. Here's what we're going to do. We know it's the same size, So we can go back up. We know that it has a radius of 1.9 centimeters. You could go through and you could plug these back in, but if you've been keeping track of your work, like I have, you know that the volume is already 28.7 cubic centimeters, because it'll be the same size. So our volume equals 28.7 cubic centimeters. That's the upside of showing your work. Sometimes what you find will come up again later. It's also good if you can read your work and follow what you're doing. So instead of simply writing down 28.7, it helps if you identify that that's the volume. Makes it easy for me to find what I'm looking for. All right, okay, so we know that the density is going to be equal to the mass divided by the volume, except this time I want to find the mass, so I'm going to get it by itself, so I'm going to multiply both sides by volume. That gets mass by itself, and I get the following relationship. I get that mass is equal to the density times the volume. Okay, well our mass will therefore be the density of gold, 19.3 grams per cubic centimeter, right? Yes. Times our volume, which we said was 28.7 cubic centimeters. I hope that's right. My mind wanders. 28.7. Awesome. So now I just multiply those out. Now remember, in this case, the cubic is only on the centimeter. We're not doing anything to the 28.7 because we already cubed to get that number. So 19.3 times 28.7, we end up with the following. The mass is equal to 553.91. We'll call it 554. Let's see what happens to our units. Grams per cubic centimeter times cubic centimeter divided by and multiplied. They actually cancel out, and we are left with the units we're supposed to have, which are grams. This is 550 grams. That's a little over a pound. That means that if we had something about this size made of gold, it would be about 1 pound. That's pretty heavy. All right, let's double check that we've actually got this right. Survey says 554.5. With the rounding, this would go up to 555. Ours might be a little bit off, but that's definitely within the 2%. So the system will actually identify this as a correct answer. The important thing is you know how to actually find these. We've got a little bit of rounding error because instead of 28.7, the computer will actually use all of those numbers because computers don't know how to use what we use, which are the significant digits. Or more accurately, I probably just don't know how to program it that way. All right, but this is how you solve this problem.